Welcome to Simplifying STEAM. Have you ever wondered how products are made on a large scale? From the clothes we wear to the cars we drive, manufacturing plays a vital role in our daily lives. But did you know that robots are increasingly being used to make these products? Welcome to the world of robotics and automation in manufacturing. First, let's define robotics and automation. Robotics is the branch of technology that deals with the design, construction, operation, and use of robots. Meanwhile, automation is the use of technology to perform tasks with minimal human intervention. So how are robots used in manufacturing? Well, they can be used for a wide range of tasks, from assembly and painting to packaging and inspection. Robots are ideal for tasks that are repetitive, dangerous, or require a high degree of precision. They can also work around the clock without getting tired or making mistakes. To give you an idea of how robots work in manufacturing, let's use an analogy. Imagine you're packing boxes for a move. You could do it manually, but it would take a lot of time and effort. Alternatively, you could use a robot arm to pick up boxes and place them on a conveyor belt. This would be faster, more efficient, and require less physical effort on your part. However, automation also comes with its own set of challenges. One of the biggest challenges is that it can lead to job loss. As robots become more advanced and capable, they can replace human workers in some tasks. This can have a significant impact on the workforce and the economy as a whole. To understand this better, let's use another analogy. Imagine you're at a grocery store and you use a self-checkout machine to scan and bag your items. This is faster and more convenient for you, but it also means that the store needs fewer human cashiers. Despite these challenges, automation also offers many benefits. It can increase efficiency, improve quality, and reduce costs. For example, robots can work faster and more accurately than humans, leading to higher productivity and lower error rates. First, let's go back in time and explore the evolution of robotics in manufacturing. The first industrial robot, called the Unimate, was introduced in 1961 by George Devil and Joseph Engelberger. It was used for tasks such as welding and die casting. Since then, robots have become increasingly sophisticated and versatile. Today, they can be used for a wide range of tasks, from painting and polishing to packaging and inspection. So how did this evolution happen? It was made possible by breakthroughs in automation technology, such as the development of computer control systems and sensors. For example, sensors are now used to enable robots to detect objects, measure distances, and even see their surroundings. This has made robots more capable and intelligent, and has enabled them to perform tasks that were once thought to be impossible. To give you an idea of how robots work in manufacturing, let's use an analogy. Imagine you're painting a car. You could do it manually with a brush and roller, but it would take a lot of time and effort. Alternatively, you could use a robot arm to spray the paint onto the car. This would be faster, more efficient, and produce a more consistent finish. Some of the most significant robotic applications in manufacturing include assembly, welding, painting, and inspection. Robots are ideal for tasks that require a high degree of precision, consistency, and speed. Robots are an essential part of many manufacturing processes today. But did you know that there are many different types of robots used in manufacturing? Let's start with Cartesian robots. These robots are named after their coordinate system, which is based on the X, Y, and Z axes. They're typically used for simple pick-and-place tasks, such as moving boxes or parts. Next, we have SCARA robots. These robots are designed for more complex assembly tasks, such as assembling products or manipulating parts. They have a rigid arm and can move in a circular motion, making them ideal for tasks that require precision and speed. Another type of robot used in manufacturing is the collaborative robot, or cobot for short. These robots are designed to work alongside human workers, assisting with tasks that are repetitive, dangerous, or require a high degree of precision. They're programmed to stop if they sense a human is nearby, making them safe and easy to use. Mobile robots are another type of robot used in manufacturing. They're designed to move around the factory floor and transport materials or parts from one location to another. They're often used in logistics and warehousing applications. Now, let's talk about how robots are programmed and controlled. Robots are typically programmed using software that allows them to perform specific tasks. They can be programmed to move in a certain direction, pick up a specific object, or even see their surroundings using sensors. To give you an idea of how robots are programmed and controlled, let's use an analogy. Imagine you're playing a video game. You use a controller to make your character move around and perform certain actions. Similarly, a programmer uses software to control a robot and make it perform specific tasks. Robots are becoming increasingly important in manufacturing, and sensors and vision systems are an essential part of making them work effectively. Sensors are devices that detect changes in their environment, such as the presence or absence of objects. In robotics, sensors are used to provide feedback to the robot, allowing it to adjust its movements or actions based on the information it receives. For example, a robot arm may use sensors to detect the presence of an object and adjust its grip accordingly to pick it up. This allows the robot to work with a wide range of objects, regardless of their shape or size. Now, let's talk about vision systems. Vision systems are used in robotics for quality control and inspection. They use cameras and software to analyze images of products and identify defects or inconsistencies. For example, a vision system may detect a scratch or a missing part on a product and alert the robot to make the necessary adjustments or repairs. This ensures that all products meet the required standards of quality and consistency. Sensors and vision systems are also used in collaborative robotics, where robots work alongside human workers. They can be used to detect the presence of humans and adjust their movements or actions accordingly to avoid collisions or other hazards. To give you an idea of how sensors and vision systems are used in robotics, let's use an analogy. Imagine you're driving a car, and you have sensors that detect the distance between your car and the car in front of you. Based on this information, your car's braking system adjusts to maintain a safe distance. Similarly, sensors and vision systems in robotics provide feedback to the robot, allowing it to adjust its movements or actions based on the information it receives. Robot end effectors and grippers are like the hands of a robot. They allow the robot to interact with its environment and perform specific tasks. Let's start with end effectors. End effectors are the tool or device attached to the end of the robot arm. They are designed to perform specific tasks, such as picking up objects, welding, or painting. One example of an end effector is the suction cup, which is commonly used for picking up objects that have a smooth surface. Now let's talk about grippers. Grippers are the part of the end effector that actually grasps or holds an object. There are many different types of grippers, such as claw grippers, vacuum grippers, and magnetic grippers. Claw grippers are commonly used in manufacturing to pick up and hold objects with irregular shapes. Another example of a gripper is the magnetic gripper, which is used for picking up objects made of metal. The gripper uses a magnet to hold onto the object, allowing the robot to move it around or position it as needed. End effectors and grippers are designed to perform specific tasks, and can be customized to meet the needs of a particular application. For example, a welding end effector is designed to hold and position a welding torch, while a painting end effector is designed to hold a paint sprayer and position it precisely. Selecting and integrating an end effector or gripper into a robotic system is an important part of the process. Engineers consider factors such as the weight and size of the objects being handled, the speed and accuracy required for the task, and the environment in which the robot will be operating. To give you an idea of how end effectors and grippers are used in robotics, let's use an analogy. Imagine you're baking a cake, and you have different utensils for different tasks, such as a mixer, a spatula, and a whisk. Similarly, end effectors and grippers in robotics are like different utensils for different tasks. Robotics in manufacturing is changing the way we produce goods. With the use of robots, companies are able to increase productivity and efficiency while also reducing costs. However, with great power comes great responsibility. One of the most important things we have to consider when working with robots is safety. There are a lot of moving parts and potential hazards, so we need to take extra precautions to ensure that no one gets hurt. When it comes to safety in robotics, there are a number of regulations and standards in place to protect workers. For example, robots are often fenced off to prevent unauthorized access, and emergency stop buttons are placed in strategic locations to quickly shut down the system if necessary. In addition, robots are equipped with sensors and other safety features to prevent accidents. These features include things like light curtains, which use infrared beams to detect when someone is in the robot's workspace, and force sensors, which can detect when the robot has come into contact with an object or person. Another important aspect of working with robots is maintenance. Just like any other piece of equipment, robots require regular maintenance to ensure they are functioning properly. This includes things like cleaning, lubricating, and inspecting the robot for wear and tear. When we maintain a robot, we're looking for things like loose bolts, worn cables, and any signs of damage. It's important to catch these issues early on so that we can fix them before they become more serious problems. In addition to regular maintenance, it's also important to troubleshoot the robot when things go wrong. This involves using diagnostic tools to identify the problem and then fixing it. When we troubleshoot a robot, we're looking at things like error codes and system logs to figure out what's causing the problem. Once we've identified the issue, we can usually fix it pretty quickly. Collaborative robots, or cobots, are a new type of robot designed to work alongside human workers. They are becoming increasingly popular in manufacturing due to their ability to increase productivity and safety in the workplace. So, what exactly is a collaborative robot? Put simply, a cobot is a robot that can work alongside humans without the need for a protective barrier or fence. This is achieved through the use of sensors and other safety features, which allow the cobot to detect and avoid collisions with humans. The benefits of cobots are numerous. First and foremost, they can increase productivity by taking on repetitive or dangerous tasks that would be difficult or unsafe for humans to perform. This allows human workers to focus on more complex and higher-level tasks. Cobots can also improve safety in the workplace by reducing the risk of accidents and injuries. For example, a cobot can lift heavy objects that would be too heavy for a human worker to lift safely, or it can perform tasks that involve exposure to hazardous materials or environments. Another benefit of cobots is their flexibility. They can be easily programmed to perform a wide range of tasks, and they can be moved from one location to another as needed. Perhaps the most important benefit of cobots, however, is their ability to work alongside human workers. This means that they can be used to augment human labor rather than replace it, creating a more collaborative and efficient work environment. Automation is changing the face of manufacturing as we know it. From assembly to packaging and inspection, robots and other automated systems are increasingly being used to improve efficiency, quality, and safety in manufacturing processes. One of the most common applications of automation in manufacturing is in assembly processes. Robots can be used to assemble products quickly and accurately, while also reducing the risk of errors and injuries. Another area where automation is being used is in packaging. Robots can be used to package products quickly and efficiently, while also ensuring that each package is uniform and meets quality standards. In many cases, human workers are still needed to oversee and maintain the automated systems, creating a hybrid workforce that combines the strengths of both humans and machines. Robotics and automation are transforming the manufacturing industry in many ways. We're seeing the integration of artificial intelligence, machine learning, and the Internet of Things to create smarter and more efficient systems. These technologies are enabling manufacturers to produce goods faster, with greater accuracy, and at a lower cost. But what does the future of robotics and automation look like? Imagine a world where factories are completely automated, where robots work alongside human workers to create products with incredible precision and efficiency. This world is already becoming a reality. There will be a growing demand for workers with skills in robotics programming, automation engineering, and data analytics. As the world of manufacturing continues to evolve, one thing is clear: robotics and automation will play an increasingly important role. From cobots to AI, the future of manufacturing is smarter, faster, and more efficient than ever before. Industry 4.0 is a term used to describe the fourth industrial revolution, where digital technologies such as the Internet of Things, IoT, big data, and artificial intelligence are transforming manufacturing processes. It's a new era of manufacturing that's all about connectivity, real-time data, and automation. To achieve Industry 4.0, manufacturing plants are becoming smarter and more interconnected. Machines are now able to communicate with each other and with human operators, thanks to the use of advanced sensors, actuators, and communication technologies. And of course, the use of robotics and automation is crucial in achieving this new level of connectivity and productivity. Industry 4.0 also brings a new era of digital manufacturing, where machines are able to create digital twins of themselves. With the use of virtual reality and augmented reality, operators can now be trained on complex machinery and processes in a virtual environment, reducing the need for physical training and increasing safety and efficiency. Industry 4.0 is a game changer for manufacturing, and it's all made possible with the use of advanced technology such as robotics and automation. With these technologies, manufacturing plants can operate more efficiently, more safely, and more sustainably than ever before. Thanks for watching. Please like, share and subscribe. We hope you enjoyed this exploration of robotics and automation in Industry 4.0.